All right, welcome back.
Mm-hmm.
I believe I've actually skipped 2006, but I'm jumping ahead to 2007. Um, a slightly harder problem, I think. Just conceptually, easier math probably.
Mm-hmm.
Um, so I've got a spring, an air track, a photo gate, and a glider. I know we aren't really the best equipped. Do you know what a photo gate is?
No.
Okay, so a photo gate, it's it's just what it sounds like. It's a gate that takes a picture, and so it gives you a timestamp of when an object passes through it. Um,
Mm.
so the instant that this glider gets pushed from the spring and passes the photo gate, it will timestamp it. So we'll know how many seconds it took.
Mm. Mm-hmm.
Okay, so we've got this setup we're using to study the conservation of energy. We've got a spring constant of 40 newtons per meter, held horizontal over this air track with one end attached to the air track. A light string is attached to the other end of the spring, connects it to the glider and MSM. The glider is pulled to stretch the string, so we're going to push, or we're going to pull the glider back and then release it. Um, Before it reaches the photo gate, it hits its maximum speed and the string becomes slack. So sometime in here, we hit max speed. Then
Yep.
we pass the photo gate and the string is being stretched. Okay.
Mm-hmm.
The photo gate measures the time t that it takes the small block at the top of the glider to pass through, so the glider has a block on top. Information about the distance and velocity are given below. And we've got this massive table of how much displacement we had for the spring to start out with. And then what was the velocity of the glider as it passed through the photo gate. Any questions just on the setup? So what's happening with our picture?
Nope.
Okay. So then first one, assuming that there's no energy lost, we need to write an equation for the conservation of mechanical energy that would apply to the situation.
Hmm. So, kinetic energy
Okay.
is converted to potential elastic.
Potential elastic. I'm going to subscript that S for um, potential energy of the spring.
Mm-hmm.
I feel like this would really be the other way, right? So we're starting with a bunch of spring potential energy and then converting to kinetic.
Mm-hmm.
So I'm going to throw this to the other side. It doesn't really matter, but I like to think of things from left to right. I don't know why.
Mm-hmm.
Okay, so what's my equation for the spring potential energy, the elastic potential energy of this?
Half kx squared
1 half kx squared. What is x?
x is displacement from equilibrium to um the maximum, maybe.
Okay, so x is x is our displacement from equilibrium, and then kinetic energy.
Half mv squared.
Okay, and then where will that v be?
V.
Yep. Which so we've got a lot of different velocities as we go, but
Oh, at maximum.
okay. Um, I'm just going to subscript that f for final.
Mm-hmm.
Okay, so somewhere before we hit the photo gate, all of that potential energy will be converted to kinetic energy.
Yes.
Okay, after that point, what happens to our energy?
Um, it goes back.
Goes back. Okay, so because we've got this string attached, it'll convert again from kinetic energy back to potential energy, and then come
Mm-hmm.
back. Okay, cool. So, uh, just said write the equation. I guess I'm going to simplify and then we're done.
Mm-hmm.
for the conservation of mechanical energy, so I still need to keep energy on both sides. So I think the only thing we can do is get rid of that 2 and then we're set. It's a little bit weird, but okay. They usually have us do like solve for velocity or something. Oops. Kx squared equals m vf squared. Okay. Then for the second part, they want us to graph v squared versus x squared, label the axes including the units in the scale, and then we've got the table here. So I'm going to do this in a different program, I think. Let me do axes first. So I'm going to make this one v squared. If this is v squared, what would my units be?
Meter square per second square.
Perfect. Not perfect, but well. And then, what about my x-axis?
X square.
Okay, so it should be x squared. And that would be measured in what units?
Meter square.
Okay, x squared measured in meters squared. Perfect. Okay, I need to plot some of these points. So let's do my units roughly going from 0 to 1.5. Okay, let's do... They're all 10 to the negative first power. So I'm going to make this 0. We'll say this one maybe 0.5 by 10 to the negative first. Um, 1 by 10 to the negative first. Okay. That's probably as far as we need to go. So none of our numbers actually make it that high. Okay. What would you use for your scale for v squared?
0 to 5. So isn't it just, I think just 1, 2, 3, 4, 5.
Yeah, that's probably fine. So I'm going to label 1, 2, 3, 4, and we'll just understand there's a 5 up top because I don't have any space left. So then we'll graph our points. So I've got 0.09. Oops. Should all be 10 to the second. My bad. Ten to the negative 2. Okay, we should be able to fit everything in this side. So I've got 0.09 and negative 0.22. So that's somewhere in here, and 0.22. 0.36 and 0.76.
Mm-hmm. And then we just plot it.
Yep. Point 0.81, 1.7. Okay, this isn't going to be perfect, but 1.2, 1.4, sorry, and 2.6. 4 and 2.6. 2.3, 4.8. 3, 4.8. Okay, so we'll pretend that was great. And how would you draw your best fitting line with this? What would you?
We just draw a linear line that passes. It's like we consider all the points and then just draw it.
Okay, how are you going to consider all the points though?
Ruler, and then
How
I
many
don't know.
points? How many points are above the line? How many points are below the line? If we do this right,
It should be half, right?
half and half. Okay, so if I do this, maybe from. Okay, that doesn't look quite right. Oops. Should do this in another layer. There we go. Okay, so maybe something like that.
Mm-hmm.
Okay. Okay, draw best fitting line. We did that. Use the best fitting line to obtain the mass of the glider. How could I get the mass of the glider out of this?
So if we find the slope, that's v square over m square, which is in the equation.
Mm-hmm.
Then we just divide by k.
Cool. So let me break this apart because I didn't do that. Okay. So you said copying this line here.
Mm-hmm.
If we divide v sub f squared divided by x squared, which would be the slope of our best fitting line here,
Yes.
I would get m divided by k, right?
Yep.
Sorry, k over m. K over m.
Okay. Mm-hmm.
Okay. So I need the slope of the line. So I'm going to look for any 2 points that are roughly on here. I think I'm going to go with okay.
Maybe we can use the third one.
Third one.
Vx squared is 3, and then 1.5 times 10 to the negative 2 and 3. Yeah, that one.
Okay, we're pretty close. And then
The next one.
Okay. 2 and 4.
Mm-hmm.
It's a little bit off for both of those, but we'll give it a shot. So we're both above by about the same amount. So, okay. So this will be 2, 4, 1.53.
Mm-hmm.
Okay. So what do I get?
Um, 1 minus. Wait, what is the number in calculator? 2 times 10 to the negative 2 minus 1.5 times 10 to the negative 2 is 0.005. And 1, that's 200.
Okay. So I'm going to go here. And this should be equal to k over m on the other side.
Yes.
And we were given k, so I can sub for that. K was 40. Okay, so I have 200 m equals 40. Therefore, our mass is what?
1/5.
Okay. Five is 0.2. I like the fraction as a calculus teacher. They'll probably want you to write it as a decimal and then sig figures. It looks like we need 2 significant figures for this.
Mm-hmm.
For both our v squared and our x squared. What are my units?
Kilogram.
Kilograms. Okay. So we're going to do the same thing now, only we're going to tilt our track at an angle. When the spring is unstretched, the center of the glider is now at height h over the photo gate. And then we're going to repeat it. If there's no energy lost, what will the new conservation of energy equation be?
Wait. We're doing D, right?
Yes.
So half kx squared.
Okay, so that's the spring potential. Plus,
Oh, there is potential gravitational.
yes, gravitational potential energy should be equal to
MB kinetic.
kinetic energy. Okay, so now I can just fill in. Our spring potential hasn't changed, so that's still 1/2 kx squared. My gravitational potential energy is a little bit interesting though. What's happening to my gravitational potential energy?
So mg sine theta.
Okay, so I'm going to have... Okay. Take another look at the picture really quick. So if I just look at this part here, we're going to have that extra gravitational potential energy based on our height and our displacement x from that height.
Yep.
So I'm going to have mg, and I want to multiply by h is how high we are. But how high we are is going to be that h that they're showing in the picture plus x sine theta, which is how much we've moved up from that h. So if I can draw on this really quick. We've got this h plus this x sine theta.
Also, h plus sine theta is the height.
Right. H plus x sine theta.
Oh, yeah, x sine theta.
Okay, so that's what I did there. So we're just getting to the maximum height. Okay, is equal to our kinetic energy, which also didn't change, 1/2 mv final squared. I can't get rid of the 1/2 anymore. There aren't m's in every equation, there aren't x's. I don't think we can simplify at all, actually.
No.
I'm going to go ahead and distribute, just in case they do that in the sheet. And we'll leave it there. Kx squared plus mgh plus mgx sine theta. Equals 1/2 mvf squared. Okay, any questions on that one?
Nope.
Okay. Part 2. Will this graph of v squared versus x squared now be a straight line? And then justify your answer.
No.
Okay, you're right. Why not?
Because we have 2x, x on left side, x squared and x.
Okay, so if I want to prove it mathematically, we could solve for v squared maybe? Okay, go for it.
So for the this one, I was trying to compare with the original one.
Ooh, the original was a straight line for v squared versus x squared. But if we change it and we lift this up, so that we're not horizontal anymore, then our v squared is not going to be a straight line anymore.
Yep.
Okay, is what we said for part 2. So I need to solve for v squared, and we'll prove that it's not a straight line.
So we multiply by 2 first.
Okay, kx squared plus 2mgh plus 2mgx sine theta is equal to mv squared.
And divide by m.
Okay, I'm just going to do that in one step, I think. So divide by m is equal to v squared.
And then square root. Oh, yeah, v squared.
Yeah, so I'm going to leave this as v squared just because our v squared is supposed to be our y value. So if I graph v squared versus x squared, we can see that this wouldn't be a straight line because we still have another x in the function, right?
Yep.
So it can't just be a straight line when I divide those. Okay, so I can say something like as there is another term with an x in it in the function. Our graph of v squared versus x squared will not be a straight line.
Mm-hmm.
What do you think the graph would look like?
It's like curve.
Yep. So when I go to take the square root, that'll become a root x. So as that term will become the square root of x if we solve for v. The function will be
Mm-hmm.
v squared. Will be curved. I'm not really sure what they want us to write exactly,
Yeah, just
but something like that probably. And I believe that's it. Yeah, that's it. Okay, so let's see how we did. And then hopefully the scoring guides will let us know what they were looking for exactly on that last part. So we've got conservation of energy. Okay, we did that. Substitution of k. I don't think we did that. I think I forgot.
was K given?
K was given, so I did not put 40 in. So I would have gotten 1 out of 2 points here. Okay, then the grid. Oops. Okay, our grid. Axis labels m squared over s squared. Okay. Linear scales plots 4 out of 5 in the right place. Okay. So we would have gotten 2 out of 3 points, I think, for this, because I didn't put the times 10 to the negative 2 before my meters squared.
Does it matter because we wrote everywhere and then
Oh, I did. Yeah, okay. So that's okay. Because I wrote the 10 to the negative 2 for all
Yeah.
of these. Okay, we're fine. So I should get 3 points there. Okay. Reasonable best fit line for 1 point. I think we're okay.
Mm-hmm.
So I'm going to do 4 for 4 there. So that was the 3 points and the 1 for the best fit line. And then we'll skip down here. So we're on C2 now. Okay, k over m is the slope of the derived data. Use the calculation. For 2 points that are roughly on the best fit line, okay? Any answer in the range of 0.18 to 0.22. Okay, we were in that range, so we should get 3 points for that.
Oh,
You okay? Are you alright?
yeah, I just heard some news.
What's going on?
No, because my dog is in other place, like my father's house, which is in other other, how do you say, state? Not city. It's
Okay.
city. And then the Chinese government blocked to move to go to other city.
Mm-hmm.
So we cannot actually bring my dog, but I think we found the solution just right now.
Okay, so your dog's gonna be alright?
I hope so, but not sure. It was just one solution, but we don't know whether it's gonna work or not.
Maybe after class. I know Victoria, she's the principal of the lower schools,
Oh.
um, has been organizing groups to help people who don't know what to do with their pets. She might be able to help you out if you get
Mm-hmm.
stuck.
Mm-hmm.
She's got this huge group of people in a bunch of different places that are helping each other out with their dogs,
Oh, only for pets?
just for pets.
Oh.
So she's a really good person to talk to. But
Mhm.
that's Miss Victoria on WeChat.
Oh.
Or you can look her up on the school website and you can get her email from there. Okay, so we've got part D.
Mm-hmm.
We need to use kinetic, gravitational, and potential energy in the equation. Recognize that the height
네.
is greater. Okay, we did get that equation. Okay, so we should get all 4 points for that.
어. 음. 탔어?
아니, 면경이 2개 있길래
코코는 뭔데?
아빠가 하라고. 돈을 좀 많이 주더라도 데리고 와요.
Okay, and then we did check no, and we've got a justification that v squared varies with both x squared, I believe. Oops. V squared varies with both x squared and x. Okay, I'm going to give that to us. So that's 2 out of 2. So we did say that we have an extra x in there, and so it's going to vary with both. Okay, so I would give us 14 out of 15 points for that. The only point we missed was,
K.
yeah, not writing out what k was in the very first step. Okay, any questions from anything today?
Nope.
Cool. So I'll link this in the chat, and then the homework will be 1 through 2 for the 2007 FRQ, which I linked on WeChat.
Mm-hmm.
And then I'll see you Monday. Have a good weekend. Good luck with your dog.
Thank you. See you on Monday.